Dear students, today I am going to explain magnetic nature of carbon monoxide. According to molecular orbital theory, carbon monoxide symbol is CO, carbon monoxide. Carbon monoxide contains carbon and oxygen, two atoms. Carbon atomic number 6 and electronic configuration 1s2, 2s2, 2p2. Oxygen atomic number is 8. The electronic configuration we all know that 1s2, 2s2, 2p4. First, we draw molecular orbital diagram for p orbitals. Here 2p2 from carbon, 2p4 from oxygen. 2p2 p orbitals are 3 px, py, pz. According to Hund's rule, we distribute electrons like this, single electrons. And also 2p4 from oxygen atom, we distribute 4 electrons. According to Hund's rule, first orbital gets 2 electrons and next 2 orbitals single electrons each. The most important part in the diagram is molecular orbitals. So the molecular orbitals pi 2px, pi 2py, these two orbitals have same energy, and sigma 2px, pi 2px star, pi 2py star, and sigma 2px star. How many molecular orbitals are present? 1, 2, 3, 4, 5, 6. So 6 atomic orbitals on both sides. The middle part on this diagram is 6 molecular orbitals. Names of the molecular orbitals in this order is very important. So here in the molecular orbitals also electrons filled according to the electronic configuration rules. Aufbau rule, Hund's rule, Pauli's rule. Here we follow Hund's rule. So pi 2px, pi 2py gets 2 electrons each because these two orbitals have same energy, and sigma 2px has 2 electrons. According to Pauli's rule, every orbital gets 2 electrons. Maximum number of electrons is 2. So pi 2px 2 electrons, pi 2py 2 electrons, and sigma 2px 2 electrons, 6 electrons. 2p2 2 plus 4, 6 electrons in atomic orbitals. So molecular orbitals also have 6 electrons. So we distributed 6 electrons in these molecular orbitals, and the remaining molecular p orbitals are empty. Okay. Next, look at these two diagrams. These two are also molecular orbitals. 2s2. This is from carbon atom, and this 2s2 atomic orbital from carbon atom. The middle part in the diagram is molecular orbitals sigma 2s and sigma 2s star. Sigma 2s, this sigma 2s orbital is also called bonding orbital. Sigma 2s star non-bonding orbitals. The electrons present in this bonding orbital is called bonded electrons and non-bonding electrons. So here 4 electrons in the atomic orbitals. Total is 4 electrons. So 4 electrons are distributed in the molecular orbitals also. Now 1s2, 1s2. Similarly, here also 1s2, 2 electrons are there, and 1s2, 2 electrons. Some of the electrons are 4. So the 4 electrons are distributed in molecular orbitals. Here we notice atomic orbitals on left side from carbon, atomic orbitals from right side from the carbon, and the middle part of the diagram is molecular orbitals. Dear students, make sure you can understand this. The middle part, sigma 1s star, and sigma 2s, sigma 2s star. Okay, these are the molecular orbitals. Now we are going to write electronic configuration for molecule, not atoms. This is a molecular electronic configuration for carbon monoxide. Sigma 1s2, sigma 1s2 star, and sigma 2s2, sigma 2s2 star, pi 2px2, pi 2py2, sigma 2px2. So no need to write empty orbitals here. Now we are going to find the bond order. This is very important part in this explanation. So bond order. The formula for the bond order is bonding number of electrons in bonding orbitals minus number of electrons in anti-bonding orbitals. Here look at the above electronic configuration. The electrons which are present in without star orbitals, sigma 1s2 is the bonding orbital, bonding electrons. 2 sigma 2s2, these two electrons are considered as a bonding electron. So number of electrons, total number of bonding electrons are 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8, 8 plus 2, 10. 10 electrons are there. And the number of anti-bonding electrons, we call non-bonding electrons, the electrons present in star mark orbitals. So how many electrons are present? Here you can observe 2 plus 2, 4. 10 minus 4 by 2 and 6 by 2, that is 3. So the bond order means the number of bonds present between the atoms. So carbon monoxide has triple bond. C triple bond O, carbon monoxide. So carbon monoxide has unpaired electrons. So it has diamagnetic in nature. The question itself says that what is the nature of carbon monoxide? Here we can find that carbon monoxide has diamagnetic in nature. If any molecule has unpaired electrons, it has paramagnetic. But in carbon monoxide, there is no unpaired electrons. All electrons are paired in the molecular orbitals. So it has diamagnetic. This is very important. So this is the end of my presentation. Thank you for watching.